So in the last video, we left that we need to figure out how to produce a member leave event, which is not necessarily one-to-one with a momentary disconnection. What I mean by that is that maybe we can use a sequence diagram here. So let's create a new diagram here. And we'll call this member leave. So let's see, we have our space channel and we have a space server. And one thing we can do is say that, and beyond that we have the Alright, so the space channel is created when you join a channel. So we should include that. Let's see, client to space channel, we'll say join. So client joins the space channel. When this happens, we can have the send a connect message to a space server, and you can have note over space server save some state, and then what happens? Then let's say that the client closes the browser. Client, okay, note over client. So if the client closes the browser, all code wipe clear. It can't send an event, but the space channel, because I think it does polling, it does a ping, and it can't find the client, then it knows it's disconnected. So then note over space channel realizes or terminates. Then I think we could here do space channel send to the space server, then disconnect, and then note over server update state. Okay, so somebody joins, this creates the space channel, and as part of the after join hook, send a message to space server. Space server maybe holds something in an ets table with the ID of the member, and if we close the browser, or we can even explicitly send a message that we're leaving, in which case we can send a message to the space server, terminate, send, disconnect, and that could update some state. Now, how do we actually emit a message? So we need to broadcast a message that the person has left. So some state, so you could save maybe member ID to disconnected at is nil. And then when you disconnect, you say update member ID with disconnected at and a timestamp. And then also send self. So can we do that? Space server to space server with, oh, it works out nicely. So we send a kick check. Okay, then here, note over the space server, remove disconnected members and send a note from space server to the space channel, which is effectively any clients that are still connected. Well, we'll say oh, no. What you'll do is you'll generate an event now. So we'll just say note over space server that we will emit event member left. Okay, so that's kind of the design. So what happens if they can leave the space with like clicking on, yeah, I mean, it's the same. If you move to another page, it will just terminate the channel. So I don't think we actually need to provide another mechanism. We will say terminate, then disconnect. Okay, so we can create this part. Then we'll have to handle this somewhere else, and that will get the member left. Let's try to implement this. So here, space channel. In the join, we've got some after join business. After join is handled in handle info, I think. Handle info after join. So we're checking the presence, and let's send a message to the space server. So we can say space server dot, and have we aliased that? We have not. Let's alias it. Alias space server. Alias xr space server. And this can just be space server and space server. We want to say member connected. And send the socket assigns member ID. So this is undefined or private. Well, at least we got rid of this message. Okay, so now we go to the space server, and we need to implement. What was it? Member connected. think I can remove some of these. I don't need pop event, whatever. Okay, stay focused, stay focused. Member connected needs a slug, and it needs the member ID. Then we'll do gen server cast, bid of the slug, and a tuple, which is member connected, and the member ID. We'll need to change this a bit because this requires the slug, which is socket assigns space ID, or no, space slug. What are the things you saved? Join, after join, and after join, member ID. Hold on. Here's the slug. Okay, we saved the slug. Okay, that's what we need. Okay, so that will, now we need to save some state. So we're calling cast, member connected. Now we need to handle cast. Define handle cast, member connected with the member ID socket. And in our after join, we created member movements and member states. And member states is a set. So they're both set. Anyone can write into it. And I'm assuming the member ID is the key. And we need to know when they were disconnected in this thing. So we're just going to assume this is an object. Now we haven't actually inserted anything in here. So when we join, maybe we need to store something in here. So we're going to get a connected event even before we get the member entered event, because this is not really even a event stream type of event. We're sort of back channeling this, and potentially space server is not the place to do this, but we'll stick it in here for now. We're going to handle cast or member connected. For now, we can just add it to the state. So state is just an object, this thing. And if you're just tracking disconnections, you can have an empty map and just remove it from the map. So that's one way. Say disconnected, make that an empty map when you create your server. And then here you'll want to say socket assigns, hold on. oh, sorry, this doesn't have sockets. This is state. Sorry, state. So state, which is an object, and we'll want to return a new state, right? No reply in the new state. So state equals the old state, and then disconnected is new disconnected. And if it's a map, we want to elixir move key from map put add to map delete map delete state disconnected. That's the map, and the key is member ID. This will be new disconnected. So what happens if you delete map.delete from here a key that doesn't exist? Okay, it's fine. Alright. So when you connect, you remove it from the disconnected list. Okay. Correspondingly, if member is disconnected, then you'll do new disconnected is map put into disconnected the member ID. In fact, this can be a you even need the timestamp. You put them in here, and you wait like 3 seconds or something. And then if they're still here in 3 seconds, you boot them. So maybe what we want is not a map, but is an elixir set. Elixir set. But what happens if you didn't give them a fair chance? Maybe that's what you want. Yeah, maybe that's why you want to check, because you'll just no, because what happens if you get one connection, another connection, and then your timer callback's coming back, and then you delete one of the old ones, the new one doesn't have a mechanism to delete it because you only allow one kick check. Let's just keep it simple. Delete everybody. So it's a set. So modules typically use map set new, contain unique elements of any kind without any particular order. So map set new blank blank blank. Elements can be inserted using map set put, and okay, I think what I want is map set. Let's go map set new, and then when you handle connected, you say new connected is map set delete, and now this will be map set put, And whenever we put something here, we'll just schedule a kick check. So how do we do this? We say process send after self. The message will be kick check, and the time will be kick check timeout. So let's set what kick check timeout is and also handle this. So if you can come back in 5 seconds, then you haven't really left. 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 500. Yeah, about, okay. A little long. That's fine. Kick check timeout, kick check timeout, kick check timeout. Here. So we send ourselves kick check. Now we need to handle info. Kick check. And we'll go and say that new disconnected is equal to state disconnected and just for every one of them, right? So we need a list. Map set to a list. Can you enum over a map step? Enum map set user. Check something. So m equals a map set new, and m equals map set what is it, add or put into map set a to put b and c, and now can we enumerate? So enum what's for each. M function. Let's just IO expect e. Ooh, so it does work. Okay, let's just do that. So kick check enum each state disconnected with the member ID And for all of these, we'll emit into ourselves, which will be what I guess you could just call handle cast, event message payload, so we'll do something like that. Handle cast event, and then message will be member left. The payload will have the member ID, and this is the member ID. Timestamp, time in milliseconds, will be, I don't know, what is this? So Elixir, milliseconds since POC. What's their time now? Date time UCT now. Date time UCT now. Pipe that to date time. Two Unix, and apply the unit in minutes. Millisecond. That's what I want. Right. Time in millisecond equal this. Sure, we don't need the data and the PID. Oof. We can provide nil, since this is happening not from a client. here. Just call handle cast. Here. Oh, hold on. Then we need to, okay, so we then handle casts for every one of these, and then we do no reply, the new state. Handle cast, undefined function handle cast. Ooh, right. I need to send a message. Let's okay, let's do base server dot cast state dot, and we have the space, right? We have the space dot slug. No, process event. Process event slug and the event, and this is the event. Isn't it? We're going to handle the cast because we have process event, slug, payload, PID. 3 things. Space server is undefined. Space server is not available or yet to define. So just this module. Go. So you'll have it process the event as a separate message to send those things out, which will actually unset but those will all be synchronous, and you need to finish your own thing, which your state will be state, and disconnected will be map set new. So cleared everybody. So this is a server generated event. Okay, does that follow this diagram? We get a join, send a connect, space server is stashing that as a disconnected map set. So let's update this. So no over, save member ID, or delete member ID from map set. If you close the browser, the space channel terminates and we need to send a disconnect, so we haven't done this yet. So space channel on terminate. Let's go to the terminate part, terminate. I guess this is the only terminate in here, terminate, one of two. It's just a spec. Alright, let's try to do some stuff around here. If okay, I think those probably. Anyway, send a message. Space server. Disconnect member disconnected. So if we have an if socket assigns member ID, which we should have one, then send the and socket assigns slug, then go disconnected, socket assigns slug, and socket assigns member ID. Socket underscore socket assigns. Now we need to go implement member disconnected. Member connected. Member disconnected. And I think this is already implemented, right? So handle cast from member disconnected, removes it out of state, sends ourselves a message after kick check timeout of 5 seconds, kick check, we'll do a handle info call and emit a message to process anybody with a member left, which will disconnect everybody, but we got to handle the special case where this thing is null. So we go into process event, or handle cast for processing the event. It'll come through here. This is a PID or nil. So if PID, that, else, well actually, send it, delegate it here, broadcast event PID, and over here, from, so we can just have two function heads for this. Copy this, if this is nil, then don't do broadcast from, just do broadcast. And everybody gets it. Okay, so once again, join space channel, emits, connect to space server. Space server deletes the member from a map set. If you close the browser, causes the space channel to terminate, send member disconnect. Let's just call reconnect. This one becomes member disconnect. And then here we put member ID into a map set, and then we send after a kick check. And the kick check, well, why don't we put this over here? Let's just go from space server, go to kick check, send after delay. We'll go kick check. Then kick check will remove so kick check, note over kick check, which is a handle info call. This will emit something to the space server, so kick check to space server, we'll call its process event API, and it will clear map set. And over here, note over space server, it will handle member left message, which also broadcasts. So space server will then broadcast member. Space server goes to space channel, broadcast member left. So it'll be something like this. And the front end needs to handle that, but let's see if we're getting it. So let's reload this, see if we're getting any errors when somebody leaves. Let's just open up localhost. Okay, so I join, and we're fine here. Insert into event stream. This is member. What is this? Event timestamp. The type. The type is member entered. Okay, member entered, and it got a position rotation. Sure. Then they leave. So I close this. We wait 5 seconds, and hopefully we'll see a message here, which is member left. Got it. And so we close the browser, so we can't see it over here, but if we had two browsers, we should see a member left on that side. So we can go to the scene manager, and we used to have a way to say that member left, right? Presence diff, remove avatar, something like this. This remove avatar. So I think we just want this. And so instead of presence diff removing our people, we're going to put this right up in here. It says, we're going to clean this up later, but right now it'll look something like if message payload timestamp message is member left. We got to add that to our signal hub types. Sorry, under types. This will be member left. The payload is who left. That's all I need. Timestamp number. Then in scene manager, I can say remove payload member ID. So what do we say for testing purposes? Let's remove him a little bit faster than 5 seconds. 3 seconds. Let's just keep it. Okay. Okay. So what do we have? We have Chrome on one side. We have Firefox on the other side. Oh, he's entered already. Right. This person enters, this side knows about it. So if we back up a little bit, there it is. It's moving around, got some data. And we're going to close this side, which is going to cause this side to delete it. So if we close this, 1,000, 2,000, 3, 4, 5, boom. Okay. So finish that part, and we'll post up the diagram.